right, good evening, everybody. Welcome back. This is our first meeting in 2 months because we did meet in December. So welcome back. I hope you all had a great holiday. And all the things. What do you have? Basically, Halloween, followed by Thanksgiving, followed by Christmas, followed by New Year's. So we had quite a busy few months there. But it's nice to see everybody back. I kind of missed a lot of faces that I haven't seen in a while. So thank you for being here. For those who don't know me, my name is Steve Bradshaw, and I sort of MC the meetings for this year. And then next year, I will pass the reins to somebody else, and they get to MC the meeting for a while. So anyway, let's go ahead and get going with today. So let me hit for hopefully this. Oops. Let's go click over here, and there we go. All right. I think we're good. All right. So first of all, for those in the room and for those on Zoom, I think we had 35 people requesting signups for Zoom tonight. So we have everybody in the room plus another 35 online. So for those both here and on Zoom, as always, welcome. You've seen this all last year. So it's as always, we hope you enjoy yourself tonight. We hope you learn something interesting. We hope you make a new friend. I met a couple of new folks tonight. I met Paul and Mary Beth. So anyway, I met a couple of new folks. And I hope you reconnect with some old friends as well, which I've done that a little bit tonight as well. One quick reminder, for myself as well, I think about it, put the phones on stun, which I just did for myself as well. I put that slide mostly in for me because I seem like I always forget it with all the hustle and bustle. So I put that in for me as much as anybody. Anyway, any visitors tonight? If so, we'd like to have you introduce yourselves. Amanda, this will be where you're with the mic. So anyway, any visitors tonight? Very simple, just your name. How did you find us? Because we are curious about that. If you have any astronomy experience at all, we'd like to hear about it. Sometimes it's zero. And sometimes it's, I'm a professor of astronomy, kind of hit and miss. And then if you have one, what's your favorite thing about space? So any new folks tonight, anybody visiting would like to introduce themselves? Got one back over there. We're going to give you a mic because the folks on Zoom can't hear until you get a microphone in front of you. So.
Thank you. Well, my name is Andrea Matthias, and this is my first meeting. Actually, I did attend probably about 5 years ago, but I recently took James's beginner's class. And I've been out to pick a post a few times now and completely addicted to it. And I'm just really happy to be here. So I guess for my favorite thing in space or about space, I would say is it's like treasure hunting for me. I do not have a go-to mount. I have an equatorial mount and I just do it by hand. And I just really want to know the night sky. And I just get such satisfaction from finding what I'm looking for. It's just exhilarating. So that's me.
Well, welcome. We're glad to have you.
Thank you.
Enjoy that star hopping as you go across the sky. So very interesting. Anybody else tonight want to introduce themselves? You don't have to, but we got one more over here.
Hi, I'm Nolan Johnston. I just moved to the area. I found you guys online. I don't have direct astronomy experience, but I work for Blue Origin as a navigation engineer. So I'm pretty interested in space exploration. And I brought my daughter along tonight to see she'd be interested at all, or, hopefully she'll last like halfway through and we'll get out and go look at the stars. But yeah, so.
Okay, well, welcome. Thank you for joining with us. Anybody else want to introduce yourselves or? I got one behind you there, Amanda.
Hey, my name's Catherine. You guys did an Under the Stars party at my kids' school, and everybody let me look through their telescopes, and it was really awesome. And they invited me to come, and so I'm finally here. I took an astronomy class like my freshman year in college and just like fell in love with it. And one favorite thing is, I don't know, I just feel very connected to the stars. I feel like that's where we're all from, so.
Okay, well, anyway, thank you. Thanks. By the way, I got introduced to astronomy my freshman year in college as well, so I share that with you. Anybody else here would like to introduce yourselves? Got one over here on the edge.
Hi, my name is Mike Borchard. My daughter lives in Tempe, so she looked you guys up, and when I'm visiting from Wisconsin for a couple of weeks here, always a good time to be in East Valley. I know you guys, I want to give a shout out for your Facebook page. And I'm happy you guys let me join, and I get great joy out of the posts that are on there. I have a club back in Wisconsin, Northern Cross Science Foundation, and you guys have done online programs for us. I've gotten in contact with a couple of you guys, and so I have a little bit of history with you guys. I really appreciate it. Always loved it that I'm here on this day in East Valley, so I appreciate it. Thank you.
Did I happen to speak remotely for you guys? Okay, I was going to say, because I know your name, and then you said Wisconsin. I'm thinking, I think I actually did a remote presentation for you guys one time. So, okay, well, nice to meet you face to face. So, anybody else would like to introduce yourselves? Anybody at all here? All right, well, thanks to all the new folks here. We appreciate your coming out and spending time with us tonight. Thank you very much. Tonight's agenda, we have our general announcements, which usually take all of 5 minutes. For those that are regular attenders, you could probably go through about the first 5 or 6 slides for me, because you've seen them now probably 10 or 12 times through last year. We're also going to talk a little bit about public outreach events. We're fairly active this time of year, and so we're going to talk about that a little bit. In fact, one of our new event coordinators is going to come up here, and she's going to talk through a couple of the slides. We also are going to mention the ASU Planetarium Pizza Party, which happens a week from tomorrow. So next weekend, a week from tomorrow, that party is finally here. We'll talk about that a little bit. We have a couple of member presentations. I'm going to do just a short one. It's really light, hopefully kind of fun more than anything, but I'll do one. And then Tom Mozdzen over here at the center table is going to do a follow-up to a presentation that he and Rick Scott did last year, a few months back. So they're going to kind of this was the project. This is where the project is now, kind of an update on that. Then we have our traditional sort of 7th inning stretch where we do our short social/bio break. And then we'll have our main speaker, Mark Johnston, who's right here next to me. He's going to talk to us for a little bit to be our grand finale for the night. And for the new folks, if you are interested, we do have our observatory here in the park next door. It is open till 9:30. So if you've never had an opportunity to look through a telescope before, it's a 5-minute walk that direction. You can go and get to the observatory and take a look through the telescope if you'd like. It's a very interesting right now. We have multiple planets up overhead. Now, by 9 o'clock-ish, probably Venus and Saturn are going to be a little bit too low to look at, but there's still several other planets, Jupiter and Mars and other ones still available to look at. So it's actually been a lot of fun looking at the sky the last few weeks. Anyway, that's it for the agenda. So general announcement, we do have a few new staff members. I just wanted to point their names out to you before we got any further into the year. So some of those folks you will recognize, but the ones I put in the blue color are the new folks that you elected back in November to be our new officers. So we have Amanda right here, who's been carrying the mic around for us as our VP. Jeff Foreman's our secretary right here. And he's taking notes and does various other things, handles all the filing and everything else for the club. Alice, where are you at? Alice, up back in the back. She's our new events coordinator. You may or may not know that because she just took that position on a couple of weeks ago. Not in November, but literally a couple of weeks ago. And she's been doing a wonderful job so far. I'm so happy to have Alice on board. And then Gordon Roster is in the back as well. Gordon is one of our new board members, although Gordon, I think, what position haven't you held at the club? Okay, so we'll take care of that tonight. So we want to get you to have a full sweep. Okay, so anyway, and then Andrew Thorpe is Andrew. I didn't see, oh, there you are, Andrew. I was going to say, I didn't see you earlier. So anyway, so those are our new folks for tonight or for the year. And we're happy to have our old staff returning and our new folks as well. In fact, I'm a returnee. I was here last year. I'll be here this year. And next year, there'll be somebody else talking to you besides me. So, all right. It's that time of year. It is January, so it's time to renew memberships. I noticed Brooks had a pretty long line at the table there earlier this evening. You can rejoin or join or whatever you need to do online or multiple different ways. That's a screen capture from our website that tells you how you can do it. So you can do it online and mail in a check. You can do it online and send PayPal, or you can just talk to Brooks directly in the back of the room there. But membership is very important. Membership dues is what help keeps the lights on, essentially. So if you enjoy the snacks on the back table and the sodas and all that, that dues pay for that. I spent fair chunk of change today on a whole lot of pizza for the event at ASU next week. So it pays for things like that. So dues are very important. So please support your club, join the membership, and pay your monthly dues. And Brooks is be more than happy to take your money. On that note, we have sort of an anonymous donor who has offered to pay the dues for as many as 10 people, as long as they're under 30. So he's trying to get maybe some younger blood in here, some younger folks. So if you have family members or anybody you know it's 30 or under and they would like to join, we have money now for up to 10 memberships that's paid for already. You just got to let me know. You can email president at EVAC online. That gets to me, and we'll get you set up with Brooks, and we'll get you going. So anyways, you have some money for dues memberships, so be aware of that. All right. Once you join, notice there is a new member guide button there on the screen. If you were to click on that, you would get basically a new member guide that comes up and kind of tells you about the club and how to get on the various email aliases so you keep informed and things like that. So that's available to you. What's happening at EVAC? A lot. Actually, this is a busy time of year. It's getting dark early still. The sky's pretty clear. We don't have the monsoon weather. It's not 120 degrees out there. So we're actually doing a lot of astronomy events right now. So it's a very busy time of year. In fact, it's awesome right now because we have 6 planets up overhead at night. That's not rare, but it's not common either. So it's nice to have 6 planets to look at. It's been a lot of fun to look at the sky. Anyway, on our website, you notice over there on the home page of our website, there is a subscribe link. You can hit that and sign up for our email alias. We do not sell email addresses anywhere. So you're not going to get spam from everybody and their brother if you sign up with us. It's just our personal list and nobody else's. And it's just a good way to have things pushed out towards you where you get announcements about upcoming events and other things that are happening. Now, if you don't want it pushed at you, you'd rather pull it in yourself, you can always go to our website again, and over on the events and meetings page, there is a calendar that shows up there. It's a Google calendar. And this is the one from this month, actually, January 2025. And notice that down there on the 15th and 16th and 17th or up to on the 10th, there are little entries there. Those are things that are happening. And you click on those and they open up and they give you the details, the location, the time, and so forth. So that's available to you as well. You can also look at our newsletter. We publish a newsletter every month that tells what's happening also. The newsletter is going to be changing a little bit. Just an FYI to the club. We've had the same newsletter the same way for, I don't know, a decade, maybe longer. I don't know. It's been a long time. And so we're switching it up a little bit. And so you might see some changes in February. That's sort of the target. But if it slips, it'll definitely happen in March. And we're actually going to experiment a little bit with the newsletter and try to get some feedback. What's working for you? What's not working for you? What would you like to see more of? What would you like to see less of? Those sorts of things to try to make the newsletter really useful and helpful to you here in the club. And so that's in the works, but another good way to kind of stay involved with the club there is with the newsletters. And then also, someone mentioned our Facebook page just a few minutes ago during the introductions. And here's our Facebook page. And it's a good way to stay just involved. This is much larger than the club. This is about 1,000 people are signed up on this Facebook page. And so people post their astrophotography pictures. They say, hey, we're going out to pick a post observing this Friday. Anybody want to go? All sorts of things show up on this Facebook page. Oh, hey, I've got this Celestron, blah, 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 that I'm selling. Anybody want to buy it? So people still use telescopes out there on the Facebook page. So it's just a nice way to stay involved. And if nothing else, there's phenomenal astrophotography pictures out there. We have a lot of very talented astrophotographers in the club, and they post pictures on Facebook all the time that are awesome. So it's a nice place to go for that. If you need equipment, you'd like to get involved, but you don't have any telescopes, here's a couple of things we can do for you that might save you a little bit of money. So out on our Facebook page, underneath the home page, if you scroll down a bit, there's astronomical equipment for sale, and we have both used equipment for sale at very reasonable prices, and we also have equipment for rent, so you can kind of try before you buy. And it's all very inexpensive. We're not making profit off of it. It's just there for your convenience and your benefit as club members or just club people. So anyway, that's available to you as well. Someone mentioned, I think it was you mentioned that going to James's classes. So we do have online learning tools available as well. Underneath news and resources, as you can see highlighted there, we have all those little blue boxes. And if you click on those blue boxes, it brings up information about whatever that topic is on that blue box. And they're cut off there, but there's actually 33 of those little blue boxes. So there's a lot you can learn there. And if you like more of a classroom situation, one of our members, James Yoder, not here tonight, he's traveling. He actually does a class a few times a year. He has a class on basic telescope operation, and he actually has another class on planetary astrophotography. And I think he just started a class, although he's gone for traveling for a couple of weeks. But I noticed I was out here a couple of weeks ago, and there was a group out there sort of starting a class. So anyways, very fun way, very informative way, very good way, hands-on way to learn about how to operate a telescope. All right, our charter as a club is to give back to the community. Do we need more chairs, by the way? Yeah, we need more chairs, I think. Okay, anyway, one of our charters is to give back to the community, so we can do so a couple of different ways. One, you can volunteer to your time to help with the observatory over there in the park. So we call it Greco by its initials because it's just easier to say Greco. Anyway, you can volunteer for that. We are open every Friday and Saturday night, weather permitting, from dusk till 9:30. And the nice thing about volunteering at Greco is you can say, I'm too busy this month, I'm not going to be volunteering. Or you can say, I'm going to volunteer this week, but I can't work this Friday or that Saturday because I have plans. And they'll work around you. So it's not going to impact your life at all, but you can actually give back by becoming a Greco volunteer. Also, if you want to, there's a second Friday star party out there in the grass below the observatory, and you can bring your telescope, your binoculars, whatever you have, and come out and join the star party. And we look through it, everybody else looks through it, the public looks through it. It's just a fun event. And actually, I think Alice will be talking about that a little bit later on, so I'll move on. The other thing that's available to you is we do have public outreach events where we go out to schools, HOAs, community centers, science centers, whatever, and we provide telescopes for an evening of looking at the stars with these public star parties. Alice, you want to kind of work your way up here? So anyway, the public outreach events, that is the URL that gets you right to the events and meetings page of our website. Once again, these star parties provide an excellent way to both serve the community, to meet and get to know fellow members. I really almost knew no one by coming to meetings, and it wasn't until I got involved with Greco and star parties and other things that I got to know people. And but be careful what you ask for, because if you spend too much time in here, they make you president. So anyway, but that's how I got to meet people. And now I just love these events because it's like old home week. Oh, hey, hi. Everybody knows everybody. It's a lot of fun. Anyway,
hello, everybody. My name's Alice Klobe. Like Steve said, I am now the new events coordinator for your club, our club. So I just wanted to share, talking about the second Friday. This was our second Friday EVAC Greco Star Party. I've been taking pictures before each party just to kind of be able to share with you on a monthly basis. Hey, this is what we're doing. So we have Gordon Rosner, Steve Bradshaw, David Perot, Don Wrigley, John Dunnigan, and then those that showed up later on, because you can show up at whatever time you want during the star party because it's sunset to 9:30. We had Caitlin Washburn, Bill Deligans, and Michael Nixon showed up. Now, next party that we did was the Smith Junior High School Star Party, and that was on Wednesday. Yeah, and so we had Brooke Schofield, Chase Anderson. Chase Anderson actually, he called himself an inactive member, but he's a member and he's a school teacher. So it was kind of interesting to show up and, hey, here's one of our inactive members that was there. So that was cool. And then Gordon Rosner, Claude Hayes, Don Wrigley, Steve Bradshaw, Jonathan SQ, Nathan SQ, and David Pro. They all showed up. And this was for a STEM night for school. And the kids loved it. We were looking at different planets. I was on the Sea Star doing the Andromeda Galaxy. And the instructor that had booked the party, she was over the hill with how well it turned out. She was very happy with the event. And I think we'll probably get that event again, maybe next year. And then we had one last night, but unfortunately it got canceled. But luckily they were very understanding of that as well. So now that I've kind of shared the fun pictures, what do you do at a star party event? Basically, you share your love of astronomy with whoever it is that has booked it. Whether it's going to be coming up, Steve's HOA is coming up shortly, or it's a school, or it's out here at Greco. You just bring your telescope, you have an idea of what you're going to be looking at that evening, and you point your telescope to it, have the guests come up, share with them what they're looking at. If they have any questions, answer that. And there you go. Now, I really want to let you guys know you don't have to have a telescope to volunteer for this. In fact, I do need some people who don't have telescopes to kind of help manage the crowd a bit. You know, our younger guests get a little carried away, and literally 2 seconds you look to go somewhere else, and they're touching something on the telescope they probably shouldn't. Or there's a line and they don't realize, hey, there's a telescope over there you can go to while you wait for the line to get shorter. So there you go. And what do we got? Oh, so here's our upcoming star parties. We have one more for January, and then the rest are for February. What I do is once you sign up to be on the lists, then I will send out towards the end of the month an email stating all of these, where they're at, all the details, what's the purpose behind it, and then I'll ask you, hey, can anybody confirm? So I have a general idea of who's going to show up. This is also on the calendar that Steve showed you. You can look on the calendar. It has the same things. I will also send you an email the day before each of these, just as a reminder, hey guys, this is coming up tomorrow if you want to attend. So I think that that's all. Yeah. Oh yeah, the most important party coming up right there. Everybody should attend that one. Yeah. Oh, maybe it's because our president has booked it, which I have to compliment our president, by the way. He is the only one that booked a party at the decent time, sunset, 7 o'clock. So next, all right. Thank you, guys.
All right. Plus, you got to meet Alice, our new event coordinator, so that worked out well. So once again, as I mentioned earlier, the long-awaited ASU Planetarium Pizza Party is a week from tomorrow on the 25th. And so I did send out a long email and Facebook post about this about a week or so ago. But here's kind of it. We have 122 people signed up for this event now. So it's going to be a huge event. The theater holds 150, so we're almost filling the theater. And the signups are closed because as of today, I've now ordered and purchased food and all that. So that's pretty much in the works now. Arrival time will be 11:45 for those attending. And what we'll do is at the theater, there's a large, almost like a museum area outside the theater where you can look at spacecraft and satellites and mock-ups of planets and more meteor cases than you ever thought you'd ever see in meteorite cases and things like that. It's a very interesting place. Plus, I've arranged for several ASU students who are attending college there to sort of act as our docents. So as you're walking around looking at stuff, if you have questions, hopefully these students will be able to answer your questions for us. And then around 12:50, we'll make our way over to the theater. We'll get all settled, and the movie's usually about an hour long, they said, 50 minutes roughly. So hopefully from 1 to 1:50, we'll be watching the show, watching the planetarium display. And then after that, we're about 50 yards away is a park area. It's kind of real pretty, a lot of Palo Verde trees, things like that out there. That's where we'll have our lunch area. And you can see the menu there. If it's raining, well, rather than being about 50-yard walk, it'll be about a 100-yard walk from the theater, because there's actually a building there with a large overhang with all these tables and chairs out underneath. And so if it's raining, we can get over there and get out of the rain where it's dry. Once again, though, they're both outside. So if it's warmer, dress appropriately. If it's a little cooler, dress appropriately, because you will be outside for the lunch portion. Notice there's the menu. We do have some raffle prizes. So Starizona down in Tucson donated some books to us, so we'll be raffling those away. We also have a kind of a large planisphere that we'll be giving away as a raffle prize. Actually, we're the East Valley, so the West Valley Astronomy Club actually donated a set of Robert Burnham's Celestial Handbook to us. So we'll have a set of those we'll be raffling away as well. And then Skywatcher. I'm sure a lot of you recognize the name Skywatcher. It's a major telescope brand. They actually donated to us a couple of Star Tracker mounts. So we'll be actually raffling off a couple of Star Tracker mounts as well. So it should be a fun time. Parking, depending on where you park, there's a smaller outdoor lot that's $6 for the day. There's a multi-story parking structure that's $16. You can try either one. The $6 lot's going to require you have a smartphone, though, because I tested this out a few weeks back, a month back really. And you go in there and basically you take your smartphone, it tells you right there, there's signs, you download an app, it took like 30 seconds to download the app, and then you prepay your parking and you walk in. The parking structure is the normal parking structure. You pull in, you get a ticket, on your way out, you put the ticket in the machine, give it your credit card, and you pay it that way. If you don't want to do the parking thing, Tom is pretty familiar with ASU since he kind of works there, and he told me that on the north side of 8th Street, they have free parking on Saturdays. So on the north side of 8th Street. And if you look at it, it's probably about a quarter of a mile walk from 8th Street over to the theater. So not too far, if you're pretty good clip, 5-minute walk or so. And there's also a light rail station up at University and Rural, which is about a third of a mile to the theater then. So you have some options for getting there as well. So anyway, I look forward to this. Should be a great event. Lots of people attending. Should be lots of fun. I'm really looking forward to it. Hopefully it'll be a great time for everybody. From the young astronomers, occasionally I get emails from kids, basically, younger folks, grammar school, junior high. They're studying space and they look at our website and they learn stuff off our website and they say, hey, I found this great website. Would you be interested in it? And sometimes they're actually pretty good. And so this week, I'm actually going to, or this month, I'm actually going to give you one from Ashley. So Ashley's mom said this was okay. So anyway, Ashley was doing her project. She came up with this website. If you want to take a picture of it, you can, but it's actually really quite good. I spent some time on it. And this is one web page. It's just, it didn't fit vertically. So I kind of put the bottom of the page kind of over the side here. But every one of those red bullet points is a link that takes you to a topic that's actually been done very, very well. So it's a very nice little website. And so we told Ashley, thank you very much. And we actually sent her a screenshot of this so she knows that she contributed to our meeting tonight. So I'm happy to take care of Ashley there. Member presentations. We have 2 tonight, myself and Tom. So let's just go ahead and get to this and get going here. So I guess I'm up. I'll stay where I'm at. Here's the thing. Looking back, astronomy during our lives. This is going to be very light, very surface level. It's nothing hard about this presentation. But the reason I did this presentation is this. 2 things happened during December. During December, is the end of the year. So a lot of broadcast or online or print media prints all these end of the year things. Oh, here were the 10 best sporting events during the year, or here's the 10 best books of the year, or the 10 best, or the 5 best movies of the year, or here's all the celebrities that are no longer with us this year. And, all those end of the year stuff we always see. And at the same time, all this is coming into me through my laptop or whatever else. My issue of Sky and Telescope magazine showed up as well. And it turns out it was their 1,000th issue. And so they had said, let's take a look back at what's gone on over 1,000 issues. So I looked at it and realized it was about 84-year time span, which really would represent pretty much the lifespan of nearly everybody in the club, from our youngest members actually to some of our oldest members. We have members here that are in their 80s, and this would cover their lifetime as well. So I thought it might be fun just to reproduce their timeline real quick here and just go through it and just see what's happened in the last 80 years, basically the lifetime of, well, maybe not mine quite yet. I got about 10 more years to go, but we have some folks that are literally in their 80s now. So let's take a quick look. So I had to split it up a little bit across multiple slides to fit it all in, but this is where it starts, 1942. So actually it was 1942 when they first detected radio emissions from the sun. Now, about 10 years earlier than that, Carl Jansky at Bell Labs had detected radio waves from space, but he was getting them from the center of the galaxy, so the hot center of the galaxy where our supermassive black hole is. But a guy from Britain, a guy named Hay, literally H-E-Y, like hey, he actually detected solar radio emissions, and we began to learn a lot more about the sun by looking at those radio emissions and seeing what the sun was doing. The Astronomy League was incorporated in 1947, and some of you are members of the Astronomy League, so that's when that was founded, not that long ago, ultimately. The Hale telescope was built in 1949. That is the telescope that's at Palomar, which is the mountains up above San Diego. I know that very well. I took a motorcycle ride there years ago when I was 22 years old, and a beautiful blue sunny day, late or early spring, wonderful ride, and finally got up there and I turned the corners, a long straight, there's the dome sitting there, and I'm thinking, oh man, I'm a half a mile away, it's gonna be so exciting. And then I hit the ice and crashed my bike. So anyway, so I never did see the astronomy. Worse yet, I had my girlfriend on the back, and I called everybody I knew to come get us, and nobody was around or available. I had to call her dad. You don't want to do that. So anyway, that was a very long, quiet drive home. So anyway, anyhow, so I almost saw that one time. Anyway, 1956, John Dobson, a lot of you familiar with him. He created his first telescope in 56. That was the year I was born, by the way. And that wasn't his mount. The Dobsonian mount didn't come across till 10 years later in 65, but that's John Dobson. That's when he sort of started doing his thing. Of course, we all know Sputnik in 1957. So that was the first satellite actually ever happened in 57. Now, what did we do as the United States in response to Sputnik? Well, we formed NASA a year later in 1958. So we're playing catch up a little bit there. The first interplanetary flyby ever by a satellite was actually in 62 by Mariner 2, and it went flew by Venus. So as it flew by, it looked down and said, wow, a lot of clouds down there. So anyway, if you don't know Venus, it's all clouds, very highly reflective clouds. So anyway, that's just a flyby. Didn't orbit, didn't land, just flew by. That's all it was capable of doing. Quasars were, they finally figured out where quasars were by 1963. If you're not familiar with quasars, it just means quasi-stellar object. Why quasi-stellar? Because they would look at these things in optical frequencies and go, well, it looks like a star, but when you look at it with other frequencies, it doesn't behave like a star. So what are those things? And in 1963, they finally figured out, oh, it's the supermassive black hole at the center of a galaxy emitting all this stuff. It's just so far away, it looks like a star, but it's actually a whole galaxy or the center of a galaxy. 65, the cosmic microwave background was discovered. Most of us are familiar with the Big Bang Theory, right? Or at least the television show, one or the other. But anyway, let's all sing it together. No, let's not. Anyway, it was the discovery. The Big Bang Theory predicts that if it's true, you should see this cosmic microwave background, but it had never been detected. And finally, in 65, they detected it, and they said, wow, that's like one of the strongest proofs that the Big Bang cosmology is probably pretty accurate. 69, need I say more? We all know that's an earmark day. I watched that from my grandfather's house in Ohio that day. That was awesome. And so obviously the astronauts landed on the moon, or if you like your social media, that's when they landed on the Hollywood set. So anyway, All right, 1970. That's I'm moving into high school now. Celestron introduced the famous 8-inch SCT in 1970. And actually, if you come to some of our star parties, occasionally you'll see one of those because a couple guys in the club actually have 70s era orange tube 8-inch SCTs. So they're kind of fun to watch. It's like a little piece of history. In 1970, also the discovery of dark matter in galaxies was figured out. They figured out, wow, there's a lot of stuff out there that we can't see, but we know it's there because it interacts with gravity. So anyway, so that's when that was discovered. 1971, hey, we improved. We had a flyby of Venus. Now we're actually going to orbit Mars. So we got better technology. And so we actually orbited Mars with Mariner 9 in 71. So we got a little better this time. 75, for those of you that love astrophotography, there's your earmark day. They figured out the CCD in 75. So if you have your little SZWO cameras or your Canon camera, whatever, it all came from there. In 1976, they had Comet West, and that was one of the 9 brightest comets of the modern era. So it was actually quite an event in 76. 77, Voyager 1 and Voyager 2 launched to go explore the outer planets and the interstellar space. Now, they launched in 77. You'll see them again later in the timeline, but many years later before they actually got anywhere because it took a while to get out there. 78 was when Robert Burnham wrote the Celestial Handbook, which somebody was going to win next Saturday as a raffle prize. And we heard about Robert Burnham last year. We had Kevin Schindler from the Lowell Observatory come in one night and lecture. And what he did is part of his talk, he talked about the life and times of Robert Burnham. And very brilliant man, did a lot of great stuff, but horribly tragic end in San Diego. So it's very sad for Robert. We had our first space shuttle launch in 81. Think about that. The first shuttle launched 44 years ago. I read that, I felt old really suddenly. So anyway, it's 81. I will love this because actually on the first Sunday in March, I will be standing next to a space shuttle. So I'm going to Cape Canaveral on that day and I'm looking forward to it. They didn't have the space shuttle display last time I was there, so that'll be fun for me. 87, the first naked eye supernova in 400 years was seen. But not from the Northern Hemisphere, so we would all missed it. It was a Southern Hemisphere event because it happened in the Large Magellanic Cloud, one of the little dwarf companion galaxies that's only visible from the Southern Hemisphere there. Obviously, light pollution was becoming a thing by 1988 because look what formed in 1988, the International Dark Sky Association. Apparently, they're not doing their job because I still see more and more light pollution. Neptune flyby completes the Voyager's grand tour. So we launched the Voyager stuff in 77, but notice it's 89 before they finally got past all the outer planets and flew by, the last 4 gas giants here. So it took them a while to get there. Notice they're still not in interstellar space yet. 1990, the Hubble Space Telescope was launched. So everybody knows Hubble, so no need to say much more about that. In 1994, even though I wasn't into astronomy, even I remember the Shoemaker-Levy 9 comet that approached Jupiter, and Jupiter's gravity broke it all up, so it became multiple chunks, and then those chunks hit all across the surface of Jupiter. And, we saw the pictures, we saw the little time-lapse photography. It was really pretty awesome to watch all that. 95, the first exoplanet was discovered around a sun-like star. Now, it wasn't an Earth-like planet, even though it was a sun-like star. It was a 51 Pegasi b, and it was what they called a hot Jupiter. So it was a big gas giant, but the reason they call it a hot Jupiter because it was down kind of where Earth was orbiting around its star. So it'd be really incredibly a hot planet. 1988, dark energy was proposed or postulated to exist because when they looked at the expansion of the universe, they said it's accelerating faster than we can account for. There has to be something out there pushing it apart. So they postulated this thing of dark energy. Now, interesting note here. I wrote this slide about 2 weeks ago. And on Monday night, just 4 days ago, I actually read a paper by a group of astronomers. They just published it. And they're postulating that dark energy perhaps does not exist. Their idea and their calculations is that they think that we could account for the expansion of the universe by rethinking through our sense of time. They said they think that we are not accounting for like Einstein's general relativity and specifically gravitational time dilation correctly. So we're not measuring the time correctly out there. And if you measure it by their thing, there's no need for dark energy anymore because this time dilation accounts for the discrepancies we're seeing and the expansion. So we'll have to see where that paper goes. It could be a fluke and it could be all new science. So it'd be kind of exciting to see where that paper goes. Notice now we finally landed on something. So we did a flyby of Venus, we orbited Mars, we finally landed on something. So we landed on Titan, the largest moon of Saturn. So that was kind of fun. In 2006, then we brought back our first samples from a comet. So NASA's Stardust mission flew out there, scooped up a bunch of comet dust, brought it all back to Earth, landed it. We actually got samples of a comet from space. So that happened in 2006. 2007, if you like fast radio bursts, that's when they were finally discovered. So they're kind of interesting little gizmos. Finally, from 1977 to 2012, finally a Voyager gets to interstellar space. So it took it a little bit of time. Okay, it's moving fast, but kind of slow at the same time. You really think about it. Actually, what's that? 77, 87, 97, 07. So 35 years to get to interstellar space. So that's relatively, that's moving pretty slow, I guess, compared to light. It's like the person I followed here tonight. They were going pretty slow. So anyway, 2015, the first detection of gravitational waves. They were postulated, but they had never been detected until 2015 at the LIGO Observatory. 2015, the New Horizons Pluto flyby. So we finally got those close-up pictures of Pluto that everybody likes. It's the one, sorry, I'm going to put that, where it has the heart shape on the planet Pluto or the dwarf planet Pluto. So we all know like to have a heart there because we all love it. Now we know it loves us back. So anyway, 2017, the first interstellar asteroid was discovered. Now we probably have other ones, but this was the first one we actually recognized as an interstellar object, something that came from some other solar system somewhere. And it's called Oumuamua, which I like to say, so I put it on the slide, Oumuamua. It's just fun. The other word I like is also kind of Hawaiian. You all know what the state fish of Hawaii is? Used to be, I have scuba diver as well. So it's called a huma huma nuka nuka akuaha. So anyway, so that's kind of fun to say too. So anyway, that's just the state fish of Hawaii. So huma huma nuka nuka akuaha. So anyway, I used to have a shirt with that on it. The first image of a massive black hole was finally delivered to us in 2019. And Arizona had a part of that, if you're not familiar with this. This picture was taken of M87. It's an elliptical galaxy out in the Virgo, in the constellation Virgo. And they used radio interferometry, a whole set of radio telescopes spread all over the world, to all collectively look at this thing to image this black hole. And over here by Safford, on our eastern side of Arizona, there's Mount Graham. And on top of Mount Graham, there are 3 observatories, one of which is the sub-millimeter radio telescope. And it was actually one of the radio telescopes that helped image M87, the black hole. So anyway, in fact, they got pictures in their control room. They're very proud of the fact they were part of that project. All right, so that's the supermassive black hole. Smart imaging telescopes debut. How many here have a C-Star S50 right now? Look at that. You owe it all to 2019 when the first smart telescope was built. So it was actually the Vaonis Stellina was the first one on the market. And then in 2022, we figured out, hey, we can change the trajectory of an asteroid because we sent the DART mission out there and kind of nudged an asteroid and knocked it out of its orbit a little bit. So it's kind of, can we do planetary defense or not? So anyway, and I don't think Bruce Willis was on that mission, but I don't know. So he's pretty good about saving the world, I guess. Let's see, 2023, active volcanism was found on Venus. So it's hard to see underneath those clouds because they're so thick and dense, but through radio waves and other things, we figured out there's actually active volcanism there. And who knows what's going to be next, because this is the end. It's basically to infinity and beyond. So anyway, so that's it for me. So Tom, I think you're up next, and Tom Mozdzen will be up next.
Thank you, Steve. Well, my talk will be short, and nobody ever got mad at a speaker for talking too short. Maybe except Abe Lincoln when he did his Gettysburg address. He got a lot of grief for that. Anyway, how many people were here in June or heard the talk part 1, intensity interval? Oh, wow, quite a few. Anyway, I've been trying to understand this for the last 4 years. A lot of false starts, like, oh, I got it now. Like, oh no, I don't got it. And finally, I think in the last 6 months, our understanding of how this works really took a big step forward. But anyway, so here we are. So Rick and I got some data in January and February of 2024, and we wrote a paper on it, and I think it's going to get accepted for this in this last round of feedback. We just have minor changes to make, so we're excited about that. But we upgraded our equipment to have more accurate equipment. And Wednesday night, Rick and I stayed up from 9 p.m. to about 2:30 in the morning, looking at one star, Sirius. So for those of you who weren't here, it's sort of simple. You point 2 telescopes at a star, and each telescope has a single photon detector. We're getting about 2 million photons per second in each telescope. And that sounds like a lot, but it's only like one every half a microsecond or so. So you go many microseconds or many nanoseconds without any photons hitting your scope. And then what you do is just like a punch card, you know, you when you go, or time clock, when you punch a time clock, going to work, what time did you get there? These detectors go to a time tagger, and they will timestamp the arrival of that photon very accurately. And what we're looking for is photons that arrive nearly at the same time. So there's a setup in Rick's backyard, 10-inch telescopes. Nobody's ever done this with 10-inch telescopes. I think half-meter telescopes is the previous record. Let's see, so this is, we use PhD2. There's the big blob is Sirius. That is sometimes a problem to guide on, but we can get really good guiding. And let's see, so what we make histograms of the arrival time of neighboring photons, and we're looking for the ones in that center bin that arrive nearly at the same time. So last year, after 13 and a half hours, 3 nights, we got this nice correlation spike. And that gave us 1 data point out of many that you probably need at least 2 or 3 data points. And that spike gets smaller and smaller as you move the telescopes apart for different observing runs. And when that spike goes completely away, then the separation of the telescopes tells you you can figure out the angular diameter of the star. So, so last night with our new and improved equipment, I remember this was 48,772 seconds of looking at Sirius. So last night was only 15,750 seconds. And we got a nice correlation spike. So we were happy about that. And I just wanted to share that. And that's all.
Hi, everybody. I'm Amanda Duval. Steve introduced me. I'm the vice president for 2025. And like he said, I am dedicated to sourcing the speakers for our club. So if anybody is interested in giving a member presentation, it could be astrophotography, it can be something you're working on as a hobby or in your work, go ahead and let me know and we can get you on the schedule to present for the group. So with that being said, I'm very excited about this speaker. I actually found him on Instagram. So if anyone has Instagram, he is at AZAstroGuy. He is the vice president of the Phoenix Astronomical Society. He is a NASA Solar System ambassador, a Telescope Live ambassador, and perhaps the most fun, he is an astronomy speaker on cruise ships. So I'm particularly excited about this topic because, as you saw earlier, we are working on our volunteer system and our outreach this year. And so we're going to learn more about Mark's journey in outreach with astronomy.
Thank you, Amanda. After that great introduction, I can hardly wait to hear what I've got to say. Okay, all right. So let's see if I can advance this. Right now, it's not advancing. Small technical difficulty. Okay, all right, fix the audio problem, but now, there we go. Okay, great. So thanks for welcoming me here. I am probably one of the most prolific astronomy outreach people in Arizona. I did about 120 events last year personally. And this week, for example, on Tuesday, I did a presentation star party for the Four Seasons. And then on Wednesday, I did a seniors group meeting in the morning. And then I did a Salt River Fields spring training astronomy outreach star party for them. And then last night, I was back at the Four Seasons again for another star party. And then I'm here tonight. And then tomorrow I'm doing a private event for someone who's proposing to his girlfriend and he wants a star party afterwards. So that's another busy week for me. All right, so let's talk about kind of how I got started. Like a lot of you, I took a telescope out to a park and I just pointed at the moon and a couple of bright planets and maybe a double star, something that's easy to see from the city. And with that, I was able to start showing people things and I could see the excitement in their eyes and the interest that the kids had, especially when they saw, the moon craters for the first time or Saturn's rings for the first time. It's always a thrill people to do that. I was doing a lot of volunteer work at Pinnacle Peak Park in Scottsdale. And so I happened to introduce myself to the guy who ran the park. And I said, I do this, astronomy hobby. And do you think maybe they'd be interested in me doing an astronomy event at the park after dark? And he said, sure, let's try it. And so they put a notice up saying there's going to be a telescope and a free astronomy event. We had about 150 people. And you can imagine the lineup with one telescope, right? So that was a little oversubscribed. So since then, that was back late 90s. We've limited it to 30 people so we don't get crazy. And they post it on their website and people sign up in RSVP now, but we got it down to a good system. But for a while, like a lot of you, I was having kids who thought my tripod was a jungle gym and going through all that kind of stuff. But that all pretty well. And I joined EVAC first, actually. I moved to the Valley in 1990. And at that time, you guys were having your meetings up at Scottsdale Community College. Some of you can remember that far back. And so that was close to where I was living in Scottsdale. So I joined the club and it was convenient, but then you guys moved down here and didn't want to face the 101 traffic all the time. So I left and then I ended up joining PAS and I'm the VP there now. And I've also been doing the Grand Canyon Star Party, which is a wonderful event. If you haven't had a chance to do that, it's always in the month of June when the new moon is present. And they have it for a week long on both the north and south rims. I normally do the north rim. It's a bit darker up there and more intimate. Smaller number of scopes, about 12 scopes versus 50 or 60 on the south rim. But I've done both. I'm doing south this year. Okay. So one of the things that I found when I was doing my star parties with the telescope is people would say, well, I want to see a galaxy. So I'd point it at the Andromeda Galaxy, which is the brightest galaxy in the sky, M31. And I'd say, did you see that little smudge? That smudge is the galaxy. And people go, oh, wow, oh, the galaxy. But, or the Whirlpool Galaxy. If you're really lucky, you can see two smudges. Okay, that's the cores of both galaxies, but you don't see any detail. And so I also wanted to show nebula, but nebula are even harder to show when you've got light pollution. So I got involved with what's called night vision astronomy. And I was one of the first people to do that in Arizona. And in the early days, it was kind of a minefield. You had to do custom products and things like that. But what these devices are, they basically can replace your eyepiece on the telescope, and you put them into the telescope. And in simple terms, the light from the telescope goes into the image intensifier. It converts it to electricity. It then multiplies it, in my case, 68,000 times, and then it converts it back into light. And so you see what came in a lot brighter than what came in originally. It's the same sort of thing that the Navy SEALs would use to see in the dark. And what it does is it allows you to see things with way more detail than you could otherwise. So I'll show some examples here. But there's M13, for example. So the advantages are you can see things that are really faint. You can see things that are impossible to see with a regular telescope. So you get way more objects that are visible, like the Horsehead Nebula, for example. I'll show an example of that. So even in light polluted areas, you can put a simple hydrogen alpha filter on your night vision device, and you can see HA objects like nebulas and so on. You can also, of course, use it terrestrially. But you don't get any more I don't see anything comments, which is a nice thing. For example, there's the North American Nebula and the Monkey Head Nebula. That's just an iPhone photograph. Put the phone on front of the image intensifier, the night vision device, and just click a picture, and that's what you get. So it's way better than naked eye. There's the M1 Crab Nebula. There's the Whirlpool Galaxy, and then there's the California Nebula as other examples. So there's some, if you have your phone out, you can take a picture of this page, and I've got other pages that would be good references for things too you might want to take a note of. These give you some links where you can learn more about it. One thing to note is that these things are ITAR restricted for the most part if they're generation 3 or above. And that means basically, technically, you have to be a US citizen to operate one or use one. You can't transport them outside the US. A few more cameras. So there's the Orion Nebula, there's the Horsehead and the Flame, and there's Barnard's Loop, and then you can see the Horsehead here and M42, the Orion Nebula down there, all in one picture. And there's the Veil Nebula. So really a lot of detail for a simple thing. So then in 2014, I was out with, my wife and I were out with friends, and they were talking about travel because we like to travel. And they said that they had been on like 46 cruises. 46 cruises? And she said, and we didn't pay for them. Said, tell me more. Okay, right. So she was an expert in art history, and she had a deal with the cruise lines where she and her husband would go on the cruise, and she would give lectures as the featured speaker about art history on the cruise line, and in return, they get a free cruise. And she said, you should apply because you're good in astronomy. So I did, and they accepted me. So starting about 10 years ago, I've been doing speaking on Celebrity, Royal Caribbean, Princess. We're going to go on Regent this year, and another celebrity cruise. And basically you get a simple room in the crew quarters with a porthole, so you give it a window, but you do get all the guest privileges, which is great, and discounts on drinks and Wi-Fi and things like that. They pay for my airfare to and from, which is nice. And the trick to make this work really well is to pick an itinerary with a lot of port stops. Okay, so for example, we have a cruise coming up in March on Celebrity from Fort Lauderdale, and there are it's a 10-day cruise, 2 days to get kind of to the islands, and then we have 6 port stops, and then 2 days coming back to Fort Lauderdale. And you only give a talk on the sea day because the idea is you want to give entertainment to the passengers when they're not off at a port somewhere. So when they're stuck on the ship all day, I give a presentation in the lecture hall. I'm not up on the deck with a telescope, doing that. That's not going to work. Okay, I'm in a room like this, except much larger, with hundreds of seats, and I'm giving the presentation at typically 10 or 11 a.m. on exploration of the universe, or is there life beyond the Earth, or whatever. I've got a whole series of presentations. So as long as I give a presentation every sea day, then that meets the requirement, and then I'm good to enjoy the rest of the cruise. So something to think about. If you're interested in that, you can contact me later. I can give you more details on it. Then I got involved with NASA. So I'm a NASA Solar System Ambassador, and that's a program that I heard about for the first time in 2017. They accept applications once a year, and I'm one of their most active members. So basically in the month of September, you're allowed to apply. You have to be a US citizen or a green card holder, and there's the link if you want to look into it. And it's a volunteer position, but basically NASA vets you to be sure that you have enough knowledge to speak confidently and comfortably about NASA missions and space exploration, astronomy, whatever, and do public outreach on behalf of NASA. And the purpose, of course, is to communicate the benefits of astronomy and investing in astronomy and NASA missions and things like that. So I've had a couple of visits to JPL in Pasadena. So I'm going to show you some pictures. There I am outside JPL. Now I was there when they were assembling the Curiosity rover. So this picture shows you the sky crane that was eventually used for that mission. And you can also see, there we go. There's the parachute they used for that mission, and there's the masthead camera. This is the twin rover. So they have an identical rover to the one on Mars. And then whenever they're going to do something new, they try it with the test one on land first, back in Pasadena, to be sure there's nothing wrong or no risks involved. Then they'll transmit the signals to Mars for the one to do it live. A lot of people do recycling, and at JPL, they do something a bit different. Rather than glass or cardboard, they have magnesium and titanium recycling bins, which is pretty cool, I thought. And so I've got a couple little short videos here. This shows you the rover actually being tested. You can see how slow it goes. It's actually moving right now, but not much. And then here, this is kind of a panning view of mission control, which is a really cool place to be. And then this is, I think, a really interesting one here. There's a table they have on the wall, one of the screens up high on the wall, and I'm not sure how well you can read it, but what they do is they list all the active missions, okay? And they've got Voyager 1 and Voyager 2. And you know how when a rocket's being launched, they go T-minus 10, 9, 8, they get down to 0, liftoff. Well, after liftoff, it's T plus 1, 2, 3, 4. And if you look here, you can see the time for this thing. It should be, Voyager 2 has got T plus 41 years, 23 days, 1 hour, 25 minutes, okay? And that was 6 years ago. So it's still going. But they track all the active missions that way with how long they've been in space. And then what also was cool is while I was there, I want you to watch this video right here. We were actually receiving transmissions from Voyager 2 at the Canberra radio telescope. So it was kind of cool that while I was there, they're actually getting data from the Voyager mission. So it's kind of fun to be there. And then, okay, this is a funny story. So all around mission control, you'll find jars of peanuts. And there's a funny story about this. So back in the 60s, there were the Mariner missions, and Mariner 1 blew up on the launch pad. Mariner 2 didn't launch at all. Mariner 3 blew up. Mariner 4 blew up. Mariner 5 lifted off and then blew up. And now they're waiting for Mariner 6. And you can imagine there was a lot of pressure on NASA not to have this one fail. And so they tried everything they could do to make it right. Mariner 6 launched. It went up in the sky, did its thing, landed, did its, mission was perfect. And so after the launch, they had a post-mortem meeting and they said, okay, what did we do differently with Mariner 6 that we didn't do with the other Mariner missions? And all the engineers and the scientists are sitting in the room. And finally, one guy put his hand up in the back and said, we handed out peanuts. And ever since then, whenever there's a launch, they hand out peanuts to all the people in the control room as good luck. And that was the lucky peanuts right there. True story. Okay, oops, I'm too far. Okay, so I do a lot of school events. I make a point to do events for elementary schools and high schools. I do a summer STEM camp in Ahwatukee every year. I do a lot of indoor presentations, solar observing events, and some night star parties too. You can see some pictures from some of those things. And it's always fun to teach the kids and see their interest in astronomy get kindled when they see things they haven't seen before. So, young kids and universities and different things. So I do that. And then I do a lot of indoor presentations. So sometimes, of course, we are dealing with cloud or high winds or other things that mean you can't do a star party outside very well. And so you get a venue like this and you can talk to people about how our sun's going to evolve into a red giant and then create a planetary nebula, or how elements are formed in supernova explosions. And you can say, this ring on my finger is actually a supernova remnant, which is true, and talk to people about things they may be wearing on their ear, or around their neck, or their nose, or whatever, that turns out to be coming from the core of a star. You can pick up a a meteorite fairly inexpensively. There's a series of meteorites called Campo del Cielo meteorites, shown here on the upper right. And in fact, there's the Tucson Mineral Fossil Show is coming up, I think February 2 to 16 or 1 to 16. And this show, there's 2 or 3 meteorite dealers who are there that are reputable, and you can get it for a pretty good price. I mean, if you go to a store, a retail store, they're going to charge an arm and a leg. But at these places, you can kind of pick through a box of meteorites and get one for 30 or 40 bucks that allows you to show somebody, okay, this thing in your hand is older than the Earth. It kind of blows people away when they see that. And they can actually touch something like that. So you can do that, and you can talk about, you know, the scale of the universe and the fact that Europa has got this icy crust with an ocean inside. There could be life there. There's a lot that you can talk about in indoor presentations that gets people interested. So I do that quite a bit as well. And then I got more involved with social media. So I got on Facebook. What's really done well for me is Threads. So as of yesterday, I was at 82,000 followers. I've got 41K on Instagram, and I got 3,000 subscribers on YouTube, and about 7,000 on TikTok. That may be gone tomorrow or the next day, but whatever. And then a few on X and elsewhere. So people are really interested. I try to post every day. I post other pictures I've taken. I do a lot of my own astrophotography, but sometimes I got space news. I'll post things like that, but just things that are interesting. A little bit of, I try to make it an interesting picture with a little bit of fact. I'll show a sunspot, and I'll talk about, you know, the umbra and the penumbra, or the temperatures, or how long the granules last, or something. Just give people a little bit of a nugget of information, but not too much in my posts. And people tend to really like that, and it's growing pretty quickly. Now, as far as monetizing goes, if you're interested in that, which of course you might probably are, what I've learned after a lot of work is that the value of things like Instagram and Facebook and Threads and X are that they can funnel people to YouTube, because YouTube is the place where you can make money. Because when you do videos on YouTube, they monetize them. They show commercials basically when people are running your videos. And then you get paid by YouTube based on how many advertising minutes go by. And so I'm getting, you know, small, you know, $100 plus per month from YouTube residuals. And I do tutorials on YouTube, like how to capture solar images with a solar telescope, how to process images, how to take the ASCAR C1 and C2 filters and make narrowband images with a one-shot color camera, you know, things like that. Technical issues on how to do astrophotography. I put together a 4K video on some of my best pictures and just posted that so people can see 25 minutes of just beautiful astrophotography. So a lot of different things on YouTube, but that is funneling things to YouTube from other channels is where you can make money. And it's a lot of people on, even though you may have tens of thousands of followers on Instagram and Threads. I mean, I'll often get from Meta, it will say payment June, you know, $2.05. That's typically what you're going to get, less than $5 per month from these other sites, which isn't much. Okay. Let's see here. So yeah, okay. So here's some tips on social media. You'll find videos are going to get better views than static images. I try to make things interesting. So here's my picture of the Helix Nebula, and watch what happens to it during this video. Okay. So one of the nicknames for this video is the Eye of God. And so I just found a similar looking eye picture and blended them back and forth. So you can also save yourself some effort by reusing information on different platforms. So you publish the same thing on different social media platforms. And you want to try and post with a regular cadence, whether it's once a week or once a day, so people get used to when they can expect to see content. And you also want to try to interact with other people, you know, find other people doing similar things, like what they do, comment on their pictures, encourage people when they're posting their first pictures, things like that. And the algorithm boosts you if you do that. Okay. We've seen that already. Okay, so I also do a lot of solar. I'm one of the most active solar imagers in the country. So you'll see a couple of solar videos that I did. I kind of learned from scratch how to do this stuff. I started off like most people with a broadband filter, just looking at sunspots. And then I eventually went to hydrogen alpha, which is what this is. This is a a certain wavelength of the sun, which is 656.28 angstroms, allows you to see this level of detail, but it requires a very special telescope with things called etalons that filter out this very narrow bandwidth from everything else on the sun. And so I did a lot of research from other people that are on social media who are doing a lot of good solar observing and solar images. I saw someone do a really good picture. I'd contact them and say, hey, how'd you do that? What technique did you use? What software are you using? What exposure time did you pick? All that sort of stuff, drilled down as much as I could. I traveled out to California to meet with some expert solar imagers and sit down with them and watch them image for a morning. I talked to a guy in Portugal who's one of the top solar imagers, did a Zoom call with him and went over, we traded notes on things. So just tried to get as much information from the outside world. And I'm also posting videos on this stuff on my YouTube channel. And so, you know, people will ask questions, which helps me learn more too, because I've got to get questions answered the way there it goes too. I got to know Andy Lunt pretty well. Andy's the owner of Lunt Solar Systems in Tucson that makes some of the best hydrogen alpha telescopes on the market. And I'm actually working with him now on some new products. So very active on the solar side, and it's one of the most popular things that I post is pictures of the sun. What's cool about the sun is it's different every time you look at it. So you look at the Andromeda Galaxy, or you look at the Dumbbell Nebula, you know, pick the object you want to look at, star cluster. They're beautiful, and maybe one night you've got a bit more aperture, or the seeing is better, or you've got maybe a better camera or something, get a better picture, but the object is the same. But with the sun, it's different, not just every day, but within a few hours, it can change dramatically. And so that's, for me, that's a lot of fun. I'll go to one of the websites that track this. There's an SDO, the Solar Dynamic Observatory website that tracks what the sun's doing every 10 minutes and posts a picture on the website. So I can just go to that website, see what's happening on the sun right now. And if I see an interesting prominence on the limb or some big filament on the surface, I'll lug out my gear and take pictures so long as the seeing isn't too bad. And that helps me, you know, be productive in solar imaging, and I can show people how it changes from day to day. And a lot of people look forward to seeing my solar stuff. Okay, let's go past that. So here's another example of a video that I did that kind of contrasts the view of the sun with a broadband filter and a hydrogen alpha filter. So here are the same sunspots in hydrogen alpha, and then in theory, this should revert to a broadband image. I blend them together. Yeah, so there's how the photosphere would look with the same sunspots. And then I go back to hydrogen alpha again. So you can see what different types of solar telescopes would provide. All right, and there's another one that was fairly popular. This one was picture of the day on space.com. Space.com publishes a number of my solar videos. So you can see this big arcing prominence on the sun. The sun is the most magnetic object in the solar system. It's got, but it has a differential rotation where the poles rotate at a different speed than the equator. And as a result, the magnetic field lines get twisted inside the sun, and often they touch, and then an incredible amount of energy is released, and that can cause prominences to come up or solar flares or things like that. Sorry? Oh, I don't see it here on my screen. It's not here. Sorry, I don't know what I can see what it says. Turn up volume. Okay, I'll exit. If I can do it up here, maybe I can. Thing is, I don't see it on this screen. Don't adjust your set. Okay. Okay. Joy of live demos. Okay. All right, here's another example. I captured the International Space Station going across the sun. It takes about 0.4 seconds generally to cross the sun. So then I did it obviously slower so people could see it. I've done a number of these. I've also captured the Chinese space station, the Taigong space station going across the sun. And it's actually fun to get the space station because you can get a lot of detail. You'd be surprised if you get your exposure right. You can see the solar panels, you can see the crew module, you can see the Dragon capsule docked to the side of it. It's incredible how much a small telescope can reveal on that. Okay, so then in 2020, we all dealt with COVID, and I found all my public events were canceled. And I didn't want to kind of sit inside all the time. And so I started to explore electronically assisted astronomy. And that's where you put a camera on where the eyepiece would normally be, and you project through a computer to a screen, and people can stand back safely and look at the screen and not have to be close to their neighbor and worry about germs. And so I started transitioning and exploring EAA in 2020. And now it's the preferred way that I do outreach. You can see some examples of some of the images that I would show on the screen. I mean, that's a pretty awesome M42 for, there's a little, you can see the little satellite going by right here. There's a little straight line. But let me go to another image. So the advantages of EAA are, first of all, everyone can see it at once. So if I have a group of 30 people, there's not 30 people in a line waiting to look in the eyepiece. They can all see the screen. I bring a television with me, a monitor. They can all see it at once. It's great for people who are handicapped, disabled, or the very young, or the very elderly. They don't need to try and look into an eyepiece and have any difficulty with focus. No concern about glasses. It's in focus for everybody. You get a much better, with a few exceptions, like I would say double stars and planets look better live through an eyepiece. But for everything else, you get a much better image. I mean, look at the California Nebula in color. I mean, it's just spectacular. And that's after maybe 20 seconds of exposure. So you get more detail. You see fainter objects. I can show Stephan's quintet, which would be invisible in a regular telescope, as an example. You can also live stream it if you want. Now, of course, there are disadvantages. It's more expensive. You have to have a camera and a laptop. It's more complicated. You got to bring a television, requires AC power. It's not great for double stars and planets, and it's hard to change magnification unless you do a digital zoom, and more complicated, obviously, but I find it gets a better result. So if you are interested in EAA, what you need to get started is a telescope, and F7 is okay, F5 is better. So if you had an F7 with a star zone focal reducer, that would be good, for example, or a SCT with a hyperstar at F2 is even better. You, of course, need a tracking mount. And you want to have go-to to minimize the time between objects. You need a camera. A good starter camera is the ZWO 294 MC Pro. And you probably want to have a couple of filters, one for broadband objects and one for nebulas. You need a laptop, some cables, monitor for a couple $100 from Amazon, and some kind of a battery. I've got a YouTube video that talks about how to buy the best astronomy battery. And it's pretty current. I just released it last month. So you might want to look at that. I go into the details on those. There's some photographs of my setup. I've got a 9¼ Celestron with a hyperstar and a camera on the front. And this is an example of what happens when you stack. So what the software and SharpCap software does on your laptop is, in my case, I'll generally take a 16-second exposure and then take another one and another one and another one. And as these pile up, the software compares each picture to the one before it. And where the pixels don't align, it throws them away. So it basically improves your signal to noise over time. So the longer you stay on an object, the more details you see in the spiral arms, the more nebulosity is revealed in the outer part of the nebula. It's great. So you can put it on the object and then leave it there and then stand to the side and talk about the object for a while and do some Q&A. And while you're doing that, the picture's getting better and better and better and better. So there's an example of the Rosette Nebula. And all right, so then next thing for me is I became a Telescope Live ambassador. So Telescope Live, you might want to check them out. They're on the web, and they have a network of telescopes around the world, in Australia and Chile, in Spain, in the US. And these telescopes, they've got everything from 1 meter telescopes down to FSQ 106 Takahashis. They wide field, narrow band. They've got CDK 24s. They can be controlled from the operator, and you can also just subscribe to get, for like $6 a month. You can get a basic subscription, and that allows you to download the subs from these pictures, and then you can process them yourself. So you get the raw FITS files, and then you take that into PixInsight or I use Affinity Photo or Photoshop or whatever software you want to use, and they're already calibrated frames. So you can just put them together and then you can practice your post-processing chops on them and create your own images. So for Telescope Live, I am their source of solar images. So I provide all of their raw solar fits files from my work, and then their subscribers can then download those and make their own solar pictures. All right, and then I'm also involved in November. I run what I think is Arizona's largest single presenter astronomy outreach event in Cave Creek. It's the Cave Creek Dark Sky Party, and we had 600 people there last year. And they're all watching. We had 4 65-inch network televisions together, and I basically controlled everything with my my laser and computer and my Schmidt-Cassegrain with a Hyperstar. And then we, showed people the sky. It was a good dark side up there. And we're basically promoting dark skies. It's the reason we do it. We're trying to make Cave Creek into a dark sky site. And then because I was never really interested in AP and astrophotography initially, I thought, well, you can just get a better picture on Google Images. Why would I bother doing it myself, right? That was my logic. And then as I got into the EAA after COVID, I found, hey, I got a pretty cool picture of the Rosette Nebula. And then I realized, well, if I took a little more time, I get a little more detail, and I kind of got sucked into the vortex of doing astrophotography. So now it's my 5th year, and I do planetary, solar, and deep sky objects. There's a really good site out by Alamo Lake State Park where this was done. And so if you look at this little animation I did for social media, I did 7 deep space targets in one night. And this just shows the time I did them and the result that I got. So it makes a huge difference if you're in a dark site, as I'm sure most of you know very well. But if you're in a Bortle 1 site, you can get away with a lot less light and still get a pretty good picture. So I try to get away to a dark site every new moon weekend and do astrophotography. I also shipped a telescope to Starfront Observatory in Texas, and I'm using that for my wide field images right now. And astrophotography is a great way to educate and entertain people when they trying to learn about this stuff. So there's a summary of what I got in one night. So it's pretty good for one night. All right, so then more recently, I became a ACEAP ambassador, and this is the Astronomy in Chile Educator Ambassador Program. So the National Science Foundation funds a very small group of people to go to Chile every summer, our summer, their winter, and go visit the largest observatories in the world and go behind the scenes and meet with the astronomers and see what science they're doing. And in theory, to take video and do interviews and take pictures and then promote it on social media. And then you come back and try to promote it with clubs like yours and other clubs, and communicate the value of the scientists being down there and try to show that it's we're getting good value for our tax dollar investing in observatories in the Southern Hemisphere. And so I'm very excited about that. We haven't got the date set yet, but it's about a 10-day trip in the Atacama Desert, seeing all the best observatories in the world in Chile. I'll be doing that sometime next summer. And so final thoughts. So I said I did about 120 events last year, and I'm retired, and this is actually a pretty good secondary income source, doing outreach programs. And a little tip, if you have your own business of any kind, then you can make astronomy outreach your charitable arm. And by doing so, you can then write off 100% of all your astronomy purchases. So all of my telescopes, cameras, filters, trips to the Grand Canyon, trips to anywhere I go in the world. I went to Namibia last year in June for the New Moon weekend with a friend, and we went to there's an astronomy camp there called the Kiritib Astro Camp, and they have mounts and telescopes set up, and you just bring your own camera and your own controller. We bought ASI airs and our own cameras, and we were able to take pictures of things you can't see from North America or Europe. And it was fabulous to be able to see Proxima Centauri and the Running Chicken Nebula and the Magellanic Clouds, naked eye, things like that. It was amazing. So it's a lot of fun when you see the young people come to these events and see the wide-eyed look they have and see the interest they have in this stuff. And that's kind of what makes it all worthwhile for me. So anyway, that's kind of my journey in astronomy. Hope that was interesting. And thanks for having me here tonight.
Does anyone in the room or on the Zoom have questions for Mark?
I'd like to hear a little more about the night vision astronomy, like what model you use, if with your telescope. Without it, what magnitude can you see versus with it, what magnitude can you see, things like that?
Okay, so the question is a little more about the night vision stuff. So it depends upon the image intensifier that you get. And I've got a whole separate presentation on just that topic, but there's a lot of very detailed technical specs that depends how much magnification you get and how much noise there is in the device and so on. But the websites that I provided can give you a lot of that information. It essentially quadruples the aperture of your telescope. Okay, so if you have a 5-inch refractor, it's now a 20-inch refractor, essentially, as far as the light gathering that you get. And then when you can put filters on it, then you can really pull out the nebula details, as you saw in some of my images, like North America and California and the Monkey's Head Nebula. It makes you be able to see those things. And then I've also got for mine a kind of a wide field lens, a 50-millimeter lens I put on. So I don't use a telescope at all. And I just hold it up and you can look and you can see Barnard's Loop around Orion and the really huge structures. And you can sweep across Cassiopeia and see the Heart and the Soul Nebula really clearly, things like that. And then the Sagittarius Scorpius region, the summer is just amazing with all the nebulosity, and through Cygnus as well on a wide field view. So you don't have to use a telescope, but obviously telescope allows you to see the fainter, farther away objects.
Thank you.
Any other questions for Mark? Cool.
Could you share a little bit more on the solar flares imaging and how you were filming them? I know it probably takes a lot to, but can you kind of briefly go over how you were filming them?
Sure. So the question is, how do I do the solar flare imaging? Well, the short answer is I've got a YouTube video. Okay. But briefly, what I do is I'm using SharpCap software, and I have a video camera on my telescope, a monochrome video camera. And I'll take about a 8 or 9 millisecond exposure, basically. And I'll run that video at like 60 to 80 frames per second. And I'll do that for about 20 seconds. And that will gather one short video block. And then I'll take a break for 15 seconds and I'll do another one and another one and another one. So I'm taking 2 or 3 per minute. I'll do that for an hour and a half or so while I'm tracking the sun. And then at the end of it, I now have 200 short videos. And then I run all those videos through AutoStacker, and that provides one monochrome TIFF file for each one. So now I basically have 200 pictures. And then I run it through other software, which does sharpening, and I add color to it, so it looks like the sun, and denoising and things like that. And then I end up with 200 good-looking pictures, or maybe I've thrown some away because they're blurry. And then I just put those in an animation program like iMovie or any kind of program at all. You just take single pictures, put them in a row, and then you run them together quickly at 24 frames per second, and you get about a 15 or 20 second animation. Yeah, check the video.
I'm just curious, and you don't really have to answer this, but what did you retire from?
So my degree originally was electrical engineering. And for a long time, I was in kind of corporate America. I was an expert in test and measurement of local area network cabling, fiber optic and twisted pair cabling. I wrote some of the standards for that. And then I kind of pivoted and I got into mergers and acquisitions. And then I started my own consulting business in kind of wireless technology and M&A for small companies in that field, and strategic planning and stuff like that for about 10 years. And then I decided to just retire about 3 years ago. So it wasn't related to astronomy at all. But when I was 10 years old, my parents gave me a 60-millimeter Tasco refractor for Christmas. And I had a cheap 10-millimeter Kellner and a 25-millimeter eyepiece. And I was out in the backyard in the snow, not knowing what I was doing. And I saw this bright object over the trees. And I looked at it with the 25-millimeter wider field eyepiece, and it looked like a little yellow football. I thought, football? What could be that oval shape? And so I took the eyepiece out and I put the 10-millimeter in and I focused it with Saturn with the rings. Okay. And I discovered Saturn when I was 10 years old. And I ran inside, Mom, Dad, you got to come see it. Drag them out in the snow so they would look. So that's how I got hooked on astronomy originally. But I've been interested ever since, and I always have had a passion for it. And I've owned telescopes throughout the period in between. But, you know, I had a real job for a long time. But now I'm basically full-time in retirement doing astronomy.
In fact, that's my question. How much time does this take to get your, subject matter, get it ready for production and then posting it?
Well, I guess it depends on what you're referring to. I put, like when I'm doing processing of photographs, I put macros together now to speed up the process. And I have a lot of one-click things I can do that normally would take you 15 minutes, I can do in a second. So I've automated my process as much as possible. And in fact, I've talked to some people about how there are now some AI agents you can build into your computer that will actually start and end programs and transfer files and do things even more automated than I'm doing it. So I'm starting to look at that as well. So part of the process is being smart about automation, also trying to reuse as much as things as you can in other platforms. So, I'll typically, if I decide that the sun's got something interesting, I've already got part of it set up. I'll have my telescope set up in 10 minutes with the solar filters on it. I'll spend 20 minutes taking images, and then I'll go back inside and take 15, 20 minutes to process the images, unless I'm doing like a big animation that takes hours. But just single images, I can do that in a few minutes. So a couple hours, maybe doing solar work. I'll end up with 3 or 4 really good hydrogen alpha images, which I can use over several days to follow. And then the night stuff, obviously you could do either at night if you're out with a scope, or I'll use my remote observatory to capture things while I'm sleeping, do that too. So try to automate as much as I can. But yeah, it does take a fair bit of time. And of course, in my evenings, I'm doing things like this a lot too, either with a telescope or in a presentation forum like this.
Any other questions for Mark? All right, well, thank you so much, sir. That was awesome.